Hello everybody and welcome back. Root Beer here with question number 18 on the 2002 Grade 11 contest, the Fermat contest. Question 18, a rectangular piece of paper, AECD, has dimensions 8 centimeters by 11 centimeters. I think that's suspiciously close to an actual piece of paper. I think a real piece of paper is 8.5 inches by 11 inches, but I don't think that really matters right now. Corner E is folded onto point F, as we have here, which lies on DC. The perimeter of the trapezoid ABCD is closest to... Okay. So, with a question like this is something you can actually try and work with an actual piece of paper. So I happen to have one lying around here. It's an old financial support form. That's not really that important. So I have my piece of paper, and I can actually bend it down. And I can bend it down like this. And I could try and visualize it like this. Not all that important, really. But with some questions, it is a nice thing to have aids around. So it's a good idea if you can bring in like tiny little wooden shapes. That's always a good idea. What else is good? Three-dimensional shapes are good, like little cubes and spheres and tetrahedra. I don't think anyone can really get dodecahedra at a craft store. Other things that are good to bring in. Scissors is always good, just in case you want to cut out something out of your scrap paper. I remember there was a question a while ago about a net. You can actually cut it out and maybe try and fold these things together. I'm rambling, but being able to bring these things in, like scissors and little extra visual aids, if you're proctor will allow, are great things and a great way to get a handle on some of the harder questions, which are visualization and geometric questions. Harder, at least for me. Okay. So we have our piece of paper. Our corner has been folded. If you want to, you can grab a scrap piece of paper to help you visualize what's going on. And we want to know the perimeter of this figure. Okay. So, I notice we got a height here of 8, and that means that we're probably going to have a height here of 8 as well. Got a nice little rectangle here. So if BF is 8, then that means BE must have been 8, and that tells us how far over B is from A. Should be the difference between 11 and 8, which is 3. So let's go draw a picture and start filling some of this stuff in. Alright, so there's E, here's F, A, B, C, and D. So we got right angles all over the place here. Now I already know that this is 8 and this is 11, so we're already on our way to figuring out the perimeter here. And if this is 8, then that means that BF is going to be 8. And if BF is 8, then that means that BE must have been 8 all along. And since we have right angles here, we're going to get an 8 down here. And what's left over? Well, in total, we have to have 11 on DC. FC is 8. That means that DF is going to be 3. 3 plus 8 is 11. Likewise, we're going to get a 3 up here. And now we're really close to figuring out the perimeter here. We have an 8, a 3, and an 11. We just need to figure out the length of BC. So there's nothing really we can do to analyze our picture to get it. All we can really do is realize that we have a right angle down here, and we have the legs of the right angle triangle. So by Pythagoras' theorem, BC squared is going to be BF squared plus FC squared. Now both of those are 8 squareds. So that's 64 plus 64, which is 128. So BC is going to be square root of 128, which is 8 times the square root of 2. Now, if I remember, they're actually asking us to round in this question. Yeah, the perimeter of the trapezoid is closest to, and then we have some options here. So at this point, you should grab out your handy calculator and try working this out. So I guess I don't want to flip a page and get away from our diagram. So we'll just say perimeter is 3 plus 8 plus 11 for DC plus 8 root 2. And that's the exact value. We can clean it up a little bit. 8 plus 3 is 11, plus another 11 is 22. So we can clean it up here, but this doesn't actually give us a decimal that we can work with. So we can grab our calculator and plug in 8 times square root of 2 plus 22. And you'll get 33.313, and so you'll know, oh, okay, it's whatever answer is closest to that. But if you forgot your calculator, and I'm only doing this just as a little aside, if you forgot your calculator, the square root of 2 is one of the little numbers that I recommend you know the first couple decimals for. Often when you're in school, when they teach you about circles and stuff, I think starting in 7th, 8th, or 9th grade, somewhere in there, they teach you about the number pi. And no one really worries too much about the 100th digit of pi, but they do tell you you should really know, pi is 3.14. In the same vein, I recommend that you know a few things like the square root of 2 is 1.414. Or the square root of 3 is 1.73, and I don't even know the next one. But I know about what these numbers are. So if I'm ever stuck in a situation where I don't have a calculator, I can try and estimate this stuff just by multiplying with that little decimal, just as you would with pi if it were a circle-type question, and you would use 3.14. It's not exactly pi, but for this sort of question, it's good enough just to have the first couple decimal places. So, if we were to go back to the question, suppose I didn't know that. Well, 22, that's fine, but 8 times square root 2, I recommend square root 2, square root 3, square root 5 isn't bad, and that's 2.23, I think, 6. The first couple of those are pretty good. So square root 2 is about 1.41. So if I want to multiply that by 8, I can just go ahead and do that. 8, and then I'll get to 2, carry a 3, 8, and a 3 is an 11. So it should be about 11.28. There's some other stuff here. And there's some other stuff here that obviously brings this up to an 11.3. But the point is 11.28 plus 22 is 33.28. And that is enough, because they're only going to one decimal place here. We're looking for the 33 or the 32. Well, here's the 33.3. Either way, if you had your calculator or if you just knew a very simple approximation, even 1.4 would have done the trick here. You can still get the answer of A for 18. Okay? Try and keep a calculator, but sometimes calculators aren't allowed for contest questions. Not for these ones, but I think there are other contests out there. Certainly there are exams I've written that you're not allowed a calculator for. And so knowing these approximations can be very helpful. So we'll get a fresh piece of paper for the next question. And that is going to be question number 19. We'll have to wait for the next video to take a look at that.